Before we kick off the series, at the end of the presentation, there will be an opportunity for a brief question and answer or Q&A session. If during the presentation you have a question, please submit it in the Q&A space on your WebEx screen, and we will ask it during the Q&A session. We will do our best to get all the questions answered. Today's webinar is on 3D printing from trash with RE3D's Gigabot X Pellet Printer. Without further ado, it is my pleasure to introduce Helen Little from RE3D. Helen is a mechanical engineer at RE3D, specializing in Gigabot X, a pellet 3D printer. Helen, I will now turn it over to you and your team.
All right, thank you so much, Jason. I'll try to be speedy so we have time for questions. So thank you everyone for joining. I'm going to be talking about Gigabot X, RE3D's pellet printer, and what it looks like to print from pellets. So first things first, looking at the additive manufacturing market, there is a gap between cheap, affordable desktop printers and large, expensive industrial printers. And that's where RE3D comes in. Who are we? We are a startup company based out of Houston, Texas, and we are a full-service 3D printing company. That means we make 3D printers, we do contract prints, 3D scanning, the whole shebang. And for the last 6-7 years, we've been making filament 3D printers. But, as you'll see soon, we have started to go into looking into building this pellet printer. So what are we about? We have a social motivation at our company's core to make 3D printing large objects accessible and affordable. And that brings us to 3D printing with pellets. So what does 3D printing with pellets look like on Gigabot X, our pellet printer? Here's a flow chart to kind of show it. So the standard 3D printing with the filament looks like you have a filament feedstock with plastic that's fed through the printer, and it is melted and extruded to create the part. And then once that part is finished, it gets used and then eventually becomes trash. But what if you created a more circular economy approach to 3D printing? So here you can see if you had the customer creating trash, that trash can then be reground into plastic particles and then remelted into pellets, dehydrated, and then put into the printer to be printed directly from the pellets instead of filament. That would then create a product, and then it goes into this circular flow. Looking instead of at pellets, what if we printed straight from trash? So trash regrind. Then we skip the process of making a pelletized form of plastic and instead just use plastic granules that would come out of just grinding a plastic using a granulator or a shredder. And what if you can put that right into your 3D printer and print a product out of that plastic? So why even do this? Why even investigate printing with pellets and regrind instead of just using filament? There are a lot of benefits over filament. It is faster, it's cheaper, it's more accessible, and there's also this environmental impact where we are facing a huge plastic pollution problem around the world, and there are tons and tons of plastic waste just being produced every day. If we can somehow take that plastic waste and transform it into usable products via 3D printing, you're solving two problems at once. You are taking plastic out of the environment, and then you're also creating valuable products and manufacturing value. Taking a closer look at the pricing of all of this, filament can be $20 to $50 US dollars per kilogram, depending on the material, and pellets are an order of magnitude cheaper than that. That's because all plastic products out there, their standard form starts as a pellet. And often plastic filaments for 3D printing were originally made from pellets. So if you can print straight from the pellets, you're essentially taking out an entire manufacturing step and all the equipment and the factories and the energy and all those costs built into that. Another benefit of printing with pellets is you can use larger layer height and have faster prints. This is especially important for really big production runs, and if you're building things on a large scale, like a human-sized print, then you don't need the smaller resolution, and then you can turn out even larger prints. So going into early prototypes, we had a Kickstarter campaign for the Gigabot X, and this is the results of it. It's based off of plastic extrusion technology for injection molding. So we have a compression screw that you can see on the right picture that melts the plastic and then physically compresses it to extrude it. And we're basically mounting that process onto the 3D printer. Here is our Kickstarter design. The extruder on the left, you can see a cross section here. We have an extruder motor mounted on the top, and that is connected to that compression screw that I was just talking about that pushes the plastic down through the extruder. And then on the outside of the extruder, we have heat zones that add heat to the system and melt the plastic as it goes down, and then it gets extruded out the nozzle at the bottom. On the right side is the frame of the 3D printer itself. This is the same as 3D's FFF filament printers. So we already have a basic framework for 3D printing. We're just adapting it to pellet extrusion capabilities. Since Kickstarter, the Kickstarter design got released, we've been continually updating and adding revisions to Gigabot X. So we've increased the fidelity of it with a metal body. We have 3 heat zones instead of 2 heat zones. We also modified the geometry of the extrusion screw so that it has slower compression and it just extrudes better. And then we also added a gravity feed system. You can see in the right side picture, there's a hopper on the very top of the machine, and the pellets fall, or the regrind falls via gravity into the extruder. And then we also have a range of nozzle sizes from 0.4 millimeters to 1.75 millimeters or even more to take care of a range of resolution and types of. So looking at how we've been able to apply this pellet printing technology in the real world, we do have an outpost in Puerto Rico, and one of the projects we did there was with a coffee farm that needed their farmers to collect coffee beans in a basket. And previously they were just using those 5-gallon Home Depot buckets, and they would cut into the worker stomachs, and if they were overfilled, it would bruise the coffee bean at the bottom. So we designed this coffee basket on the right that is printed from pellets made from recycled water bottles created in the Netherlands. So this is a 100% recycled solution, and it is also adding values to this coffee farm. Also looking at resiliency, we started a partnership with the Habitat for Humanity out of Austin, Texas, 3D printing furniture parts out of completely recycled plastic. So right now we are working on printing chairs, tables, and benches with the same PET water bottle plastic, and then combining that with reclaimed wood from Habitat for Humanity's Restore. Another very important thing that you can 3D print out of pellet printers is lab equipment. So lab equipment is very expensive. If you can create a lower fidelity version off a 3D printer, then you can bring education and science access to more remote regions of the world that may not have access to higher fidelity scientific instruments. So the possibilities are endless. We're discovering more and more every day what the applications can be. So looking at materials we've tested so far, we have tested a whole range. Your standard ones like ABS, PLA, polycarbonate. But then looking into some more exotic materials, PLAs that are filled with other materials like copper, which is really great for radiation shielding, and then bamboo, which can be sanded to have a wood-like texture. Another thing is TPUs. So those are flexible materials. What's great about pellet printing TPUs over filament is that some TPUs are so soft that they can't be made into filament, but they can still be printed using a pellet printer. We're also testing recycled materials. So because we are a full service 3D printing company, we have a lot of failed prints or supports and rafts from our printing processes in-house. So we save those failed prints and then we regrind them in our in-house granulator and then print with that regrind. So the top left, you can see PLA, what it looks like before and after par cooling, PETG. We have also done polypropylene from manufacturing waste. There's a company in Puerto Rico that makes some medication, and they have these test tube holders to hold the test tubes during the manufacturing process. And after that, they just throw the test tube holders out because of FDA regulations. And so they generate a bunch of clean polypropylene trash, and we've reground that and printed with it. We've also been trying to apply some scientific and research rigor to this entire process of finding out how well pellet and regrind can print with Gigabot X. So one thing that we've been doing is particle analysis. There is an open source software called ImageJ that can count particles and calculate the area of them. And we've determined that the optimal flake size for regrind is between 1 and 5 millimeters in any dimension. That means it flows through the system well and it can extrude well. One really big challenge that we've had is water bottles. Water bottles are a huge source of plastic pollution around the world. And it would be a huge win if we can 3D print with water bottles. The only issue is that the thin flake created by the thin water bottle plastic doesn't extrude very well. So we've been working on how to figure out how to get around that, and things like sifting the flake to make it smaller, flash heating it to try to make these particles curl. And then we're also looking into a cramming device that I'll get into later. Another challenge that we're looking into is a heated environment or heated enclosure. That's very important for materials that warp a lot, so like HDPE, polypropylene, polycarbonate, especially polypropylene and HDPE because those are often found in waste materials. And if you can have a heated enclosure during printing, that would increase interlayer adhesion and mechanical strength, which also applies to those high temperature, high strength materials like polycarbonate, PEEK, and ULTEM. We are currently doing a NSF grant with NSF to develop the Gigabot X printer, but we also have an additional grant to develop a high temperature enclosure. We've also been doing scientific publications. We have done a lot of collaborations with different universities, one of them being Michigan Tech. And we have published research out there right now in open source journals talking about 3D printing with Gigabot X out of recycled polycarbonate. So where are we now? We have GBXs sold. 5 might be a little bit outdated. That number keeps changing. But there are these printers out there in the wild right now printing. A lot of them are with universities who are using them to test their proprietary polymers that they're creating. But there's a huge variety of applications. There's one university that is trying to print boats out of this. So the possibilities are endless. We're also collecting a lot of customer feedback around not only how they operate the machine and how we can better service them through customer service, but also what kind of applications do people envision for pellet printing? What do they want to accomplish? What kind of materials do they want to recycle? What things do they want to print? And then how can we help improve the machine to address those motivations? We're also doing a ton of material testing. We get a lot of material samples in from various companies. Some are pellets that are virgin from companies who are creating their own polymers. Some are recycled pellets from big name companies that produce a lot of packaging waste through their manufacturing processes. They turn them into pellets and they need to use those pellets as something. And then other companies that are just, they're not in the manufacturing space, but maybe they sell a lot of food products or cleaning products, and they have a lot of packaging waste that they need to recycle in some capacity. We're also looking into developing other add-on features to the Gigabot X to improve that, close that loop on that circular economy. So part cooling and heating, granulation, drying, so that it becomes an all-in-one machine where the end vision is that you can put a water bottle in it and then it does all of it for you and prints out a part. So what's next for us? We definitely want to be printing with water bottles. I kind of mentioned some of these already. We want to create a desktop granulator also. All the granulators on the market are designed for gigantic factories and they're bigger than me as a person. If we can create a desktop version of it, that makes it a lot cheaper and more accessible for a small operation or a small business to have one or a few, and then use that to grind up their plastic waste into printable regrind for the Gigabot X. We're also developing a high temperature enclosure to enable the printing of materials prone to warping or high temperature materials. Various improvements on GBX, and then also looking to do strategic partnerships with various companies to print with their trash. There are so many companies out there who just have trash stockpiling in warehouses and they don't know what to do with it. Looking ahead to some of these updates that we're working on, we are working on this granulator. It's sized to take 1 liter PET bottles, and we're developing this as part of our NSF grant, and hopefully it's done in the next 6 months, but stay tuned for that. We're also looking into part cooling, and I guess not just part cooling, but part heating. So this would be on a temperature feedback loop so that it can blow not just hot, cold air, but also air heated to a very specific temperature. So that would help improve just the quality of prints, but then also if you have a high temperature material, it would deliver right at the part. This has been in development in collaboration with MTU, and it should be on schedule to be finished by this summer. Going back to printing with water bottles, we are also developing what we've been calling a Crammer, and it physically pushes material into the extruder. So this would work really well for some of that thinner, fluffy material like PET water bottle flake that doesn't extrude well because of the shape of the flake is preventing it from going into the extruder via gravity alone. It would also work with sticky materials like PPUs. Those plastics tend to stick together and clump together, so they don't flow as well. So feel free to follow our journey. We are constantly updating things. We do have a website and a forum on that website where we post updates constantly to what we're doing at GBX, the new materials we've tested, those results, new updates, new applications, the whole shebang. We really want to engage the community in this because 3D printing with pellets and plastic waste is such a new field, and we are still learning the applications out there. So please get involved if you have any interest in this field, and I hope that we can figure out how to solve the world's plastic. And we also have all this social medias that you can follow us on. All right, I think that concludes the talk. I know I kind of zoomed through that. But
all right. Yes, thank you, Helen. Yeah, we will now head into the Q&A session. If you have any questions for Helen and you haven't done so already, please type it into the chat box. So I do have one question here. What are some of the other applications for pellet printing?
Sure. So for pellet printing, it really lends itself to very large parts because the material is so much cheaper. That means that your material costs will scale with the size of your part. So it makes the things on the scale of boats a lot cheaper. Construction materials, we're looking into walls. Trying to think off the top of my head what we've made. Chairs, furniture, vases. There's a huge range. So I hope that answers the question.
Okay, so so the Gigabot X, it can print from pellets, or you can just grind materials and put those straight into the printer?
Exactly, yes.
Okay, great.
There are some pellets out there that are recycled themselves, so they're made of recycled materials that have been formed into pellets. But of course, there's an additional price built into the cost of such pellets because they had to be manufactured like that. So you can also print with just regrind.
All right, great. I think that was all the questions that we got. That will wrap up today's TRX webinar series. I would like to once again thank Helen. If you have any further questions for Helen Little, please reach out to her directly at www.re3d.org. There will be a post-webinar survey going out to all those who participated. We do really appreciate the time you take to provide American Makes feedback so we may continue to improve and strengthen the additive community. And a reminder, if you think that you or your organization will be interested in sharing on the TRX webinar series, please fill out the form that follows the presentation or reach out to myself, Jason Thomas. Thank you, everyone. Have a great day.
Thank you.